Imagine going through your entire life, having a job, a family, only to discover that you're missing almost all of your brain. It sounds impossible, but it's a real medical phenomenon.
One of the most famous cases involves a Frenchman. He lived a completely ordinary life, yet a brain scan for a minor complaint showed that 90% of his brain matter had been replaced by fluid.
How can this happen? The answer lies in a slow-developing medical condition and the brain's incredible, almost superpower-like ability to adapt and reorganize itself. In this lesson, we'll explore these two concepts, hydrocephalus and neuroplasticity, to understand how someone can not only survive, but function with a fraction of a brain. So, what caused the man's brain to virtually disappear? The condition is called hydrocephalus, which literally means water on the brain. In a healthy person, the brain is protected by cerebrospinal fluid, or CSF, which circulates and is reabsorbed by the body. With hydrocephalus, a blockage stops this fluid from draining. Over time, the fluid-filled chambers inside the brain, called ventricles, begin to expand dramatically. This buildup creates immense pressure, slowly and gradually compressing the brain tissue into a thin layer against the inside of the skull. Because this happened over decades, starting in infancy, the brain had time to adapt to this extraordinary change. But how can a thin layer of brain tissue do the work of a whole brain? The answer is a remarkable property called neuroplasticity. Neuroplasticity is the brain's incredible ability to change and adapt. It's not hardwired like a computer. It can literally rewire itself when it needs to. In the case of the Frenchman, as the fluid slowly compressed his brain over 30 years, the remaining neurons had time to form new connections and take on the functions of the parts being destroyed. Essentially, his brain consolidated all the most critical functions into the small amount of tissue that survived, allowing him to lead a normal life. Cases like this force us to ask profound questions about the brain and even the nature of consciousness itself. First, it shows that the brain has an incredible amount of redundancy. It seems we have significant spare capacity that can be called upon in emergencies. It also deepens the mystery of consciousness. If not in the bulk of the brain tissue, where does our sense of self come from? Crucially, the key is the slow pace of change. The brain's plasticity needs time to work its magic. A sudden, traumatic loss of this much brain would be fatal. Finally, this provides hope. It demonstrates the brain's ultimate potential for recovery, inspiring new approaches to treating brain injuries and neurological disorders. So while shocking, this case isn't just a medical curiosity, it's a window into the profound resilience and adaptability of the human brain. Let's quickly recap the incredible chain of events that allows someone to live without most of their brain. It begins with a condition, hydrocephalus, which causes a slow, relentless buildup of fluid. This leads to the physical effect, the compression of brain tissue against the skull. The brain's amazing response is to engage its power of neuroplasticity, rewiring itself to save critical functions. And the final, astonishing outcome is a person who can function in the world, their consciousness and abilities preserved in a tiny fraction of their brain. This case is a powerful testament to the resilience and mystery of the human brain.